It goes from like really great to like okay.
Alright. Let's take a look at graphing sine and cosine here. So this activity didn't seem to go too well for some of us.
Oh boy.
Maybe the most important thing in being able to shift sine is understanding where sine is before we shift it. Okay, so this is one period. Right? One period means it's going to repeat after this. Okay, so from 0 to 2 pi, we start at 0, 0, and then the key points are kind of the maximum here at pi over 2, 1, x-intercept at pi 0, minimum at 3 pi over 2, negative 1, and then another x-intercept at 2 pi 0. Okay, so we really need to understand that the sine curve, one period of the sine curve, has this shape. Right? For, I guess then here's a good picture of the repetitiveness of sine. Okay, we can see that this is that one period that we just looked at, from 0 to 2 pi, but it just continues to repeat itself forever in either direction. Okay? Same idea with cosine. Okay? In order to graph all of the shifts that we're going to look at, we really need to understand what one period of cosine looks like. And hopefully, at least got that much out of that activity. So for cosine, we start at the point 0, 1, and then our key points, and our intercepts, mins, and maxes. So we pulled all of these values from the unit circle. Right? So 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. Right? Mins, maxes, and x-intercepts are our key points of the cosine function. And again, we can say that's just one piece, one period of that function. It continues on forever like that in both directions. So one thing that we can see, both the sine and the cosine function look really, really similar. Sine and cosine are actually the same graph, just shifted pi over 2. If I were to start here, remember this is the cosine function, if I were to start here and draw that piece of the graph, that looks exactly like one period of sine. Okay? So don't forget how closely related these graphs are. Right? So now let's talk about all of the different shifts. Right? So by the end of that activity, you built something like this. Y equals A times the sine of B times x minus C plus D. Okay? Or the same thing for cosine. We can say y equals A times cosine of B times x minus C plus D. So each of these 4 values shifts the curve in a specific way. Okay? The A value is the amplitude. Okay? Amplitude is like a vertical stretch. Our B value changes the period. Okay, we'll do a bunch of examples of these here. I just want to write down what all 4 of these values do first. So the B value changes the period. And what that means is that's like a horizontal stretch.
Mr. Fetch, you kind of look like my grandma there reading that.
I just couldn't read. Super sloppy.
Are you nearsighted or farsighted?
I am nearsighted. I can't see.
Nearsighted.
So what that means to change the period, that means that is a horizontal stretch or shrink. Right? The C value, these lovely drawings. This C value is a horizontal shift. So the B value stretches or shrinks. The C value just moves horizontally. Right? So horizontal, I'm going to call it a shift. Okay, so stretch is when we're elongating or shrinking. Shift is when we're just taking it and moving it side to side. The D value here at the end then is a vertical shift. Right? So that's just going to take a function and move the whole thing up, move the whole thing down. So throughout the activity, we're supposed to discover those things. That's what the point of that was. So let's start by looking at a few examples. Let's say we want to look at y equals 3 times the sine of x. Okay, we'll go through a few simple examples and then we'll kind of build and throw in more of our shifts here. So the first thing that we want to think about is, what does the original function look like? Right? I know one period of sine is going to start at 0, 0. I'm going to go up, down, and finish on the x-axis again. So the only thing that's changing from my original function to this function is the amplitude, okay, the A value. So I'm vertically stretching it. So I'm not changing anything on the x-axis. So what I can do first is lay out my key points. Right? I know that one period starts at 0 and ends at 2 pi. Right? So what we want to do is split that interval up into fourths. Okay? Once we determine where we're starting and where we're ending, we want to split that up into fourths. If we're not shifting at all, if we don't have any B or C values, that's pretty easy to do. So I know I'm starting at 0, ending at 2 pi. Each quarter of that length, right, would be 2 pi and 3 pi over 2. Okay, but no matter what these our starting and ending values are, I'm going to split those into fourths to get my key points. So for every period of sine and cosine that we do, we should have 5 key points on the x-axis like this. And we'll look at examples where those change here in a little bit. So now, I know that my amplitude is changing. It's being multiplied by 3. Normally, we said the maximum of sine is 1. We would go up to a value of 1, down to a value of -1. The amplitude is 3. I'm just going to multiply that by 3. So instead of having a maximum of 1 at pi over 2, I'm going to have a maximum of 3. And I'll still cross the x-axis at pi, my minimum value then is going to be negative 3 at 3 pi over 2. And I'll come back to the x-axis at pi. So this would be what y equals 3 sine of x would look like. Okay, so the key things that I'm going to be looking for on these graphs are labeling your 5 key points on the x-axis. Okay, you're starting your ending point for one period, and then cutting that into fourths. So our normal starting period for sine and cosine is 2 pi. We'll be going from 0 to 2 pi if we're not shifting at all. Okay. Questions so far? Right, so again, we really have to understand what sine looks like before we shift. Right, so we have to understand we're starting at 0, we're going to a maximum of 1, crossing the x-axis, minimum of negative 1, going back up to the x-axis. Okay. So before we look at B and C, let me throw on a D value. So let's do something like y equals 2 cosine of x plus 2. Now let me make the numbers about plus 3. Alright, so we said the D value is a vertical shift. That's just going to take the whole graph, shift it up, shift it down. So whenever we have a D value, that's kind of where we want to start. Right? We can think about shifting what we call the midline. So if I'm going to graph cosine real quick here. So this is what our cosine function would look like at one period of cosine. We can think about a midline going right through the middle, okay, on the x-axis. What this value does, the easiest way to think about it is it just shifts where the middle of the function is. Okay? So normally the middle of the function is on the x-axis. If we have a D value, the middle of the function is going to be wherever that D value is. So if I'm shifting up 3, the middle of my function is going to be at y equals 3. Right? So I'm going to sketch in a dotted line. Okay? You don't have to sketch in a dotted line if you don't want to, but that's how I like to keep my midline straight. So I know that excuse me. I know that my midline, the middle of my function, is shifted up 3, and then in this case I also have an A value. I'm changing the amplitude. So what that means is from the midline, my maximum is going to be up 2 from that. My minimum is going to be down 2 from that. Right? So we're not shifting horizontally at all. So these are still going to be my key points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now, if this is my midline, and I'm going up 2, we know that cosine starts on the y-axis. It's going to come down and cross the midline at pi over 2. The minimum value then is at pi. And my minimum value is 2 away from the midline. Because my amplitude is 2. So I'm going down 2 from the midline to get to my minimum. Then at 3 pi over 2, going back up and crossing the midline. 2 pi, I'm back up to my maximum. So, and for cosine, make sure you're not drawing a B and make it look like it's going to be a periodic function. Okay, don't just draw a B between your 5 points there. Right. So the D value shifts where the middle of the function questions on something like that? Alright, let's take a look at some B and C values then. Let's do one at a time before we combine them. So let's start with a B value. Let's say we have something like y equals sine of 2x. Okay, where we just have a B value. The B value, we said, changes the period, and that's going to stretch it horizontally. The way we find our new period, you may star this in your notes. Period is just equal to 2 pi divided by the B value. Right? So in this case, my B value is 2. So for this specific function, my period is going to be 2 pi over 2, which would just be pi. Okay? So what that means, okay, normally my period is 2 pi. This function is saying, well, I'm going to shrink that, and one period is now going to occur just between 0 and pi. So when we graph them, okay, we still want to stretch it out enough to where we can see the shape. Okay, so now I'm just going to say my period is going to go from 0 to pi. And to get my key values then, I want to split that interval up into fourths. So I think the easiest way to do that is start by finding the middle point. If we're starting at 0, that's really easy. Once we start looking at where we're shifting left or right, that gets a little bit weirder. So the foolproof way of doing it is just take the average of your starting and ending point. That's going to get you to the point right in the middle. Okay. So if we take the average of 0 and pi, we add them together and divide by 2. So 0 plus pi divided by 2 is pi over 2. Right? For this function, that should be pretty obvious. Okay? But again, once we start shifting left or right, that'll be a nice way to find these values here. We can do that again to find this value. If I take the average of 0 and pi over 2, that's going to be pi over 4. Same thing here. This would be 3 pi over 4. Right, so nothing else about this function is changing from what sine normally looks like. Right? I don't have an A, a C, or a D value. So we can go ahead and sketch in our function. I know that sine starts on the midline, up to a maximum, back down to the midline, comes up like that. Okay, so again, what I'm going to be looking for are your key points, the correct function. Right? I mean, this is sine, so we know that we're starting on the midline, going up and then back down, and then the correct mids and maxes. And so my amplitude is just 1 here. So my max should be +1, mid should be -1. And those are the things that you're going to be looking for when we're graphing this. Questions so far? Alright, let's try a C value then. So let's do cosine. How about y equals cosine of x minus pi over 4. So the C value shifts the entire graph left to right. Now, we looked at shifting of generic graphs in the first semester. And whenever we had x minus something inside of the function, that actually meant shift to the right. Right? So you make a note of that. Minus means to the right. If we would have been adding in here, that means we would be going to the left. So our normal period for cosine is 0 to 2 pi. I'm shifting that to the right, pi over 4. So my starting value, instead of 0, is now going to be pi over 4. My ending value is going to be 2 pi plus pi over 4. So 2 pi plus pi over 4 would be 9 pi over 4. So I went from 0 to 2 pi, and I just shifted that pi over 4 to the right. So all I did was add pi over 4 to my starting point, and add pi over 4 to my ending point. So now we want to find our key points in between those. So this is where that average idea may be a little bit easier to find these values. So the point that's right in between pi over 4 and 9 pi over 4, I add those together and take the average. Right? So add pi over 4 and 9 pi over 4 and divide by 2. So that would be 10 pi over 4 divided by 2, which would be 10 pi over 8 or 5 pi over 4. Okay? And again, if you can do that without taking the average, that's perfectly fine, right? We're essentially just finding the midpoint between 1 and 9. So halfway in between 1 and 9 is 5. This is just a foolproof way to do that that'll work every single time. Then again, we're doing the same thing to find these two key x values. So halfway in between 1 pi over 4 and 5 pi over 4, take that average, 3 pi over 4, halfway in between here, get 7 pi over 4. So these are my key x values. So now, we just need to think about the shape of the cosine curve. So I know that cosine starts at its maximum value. I don't have any amplitude change, so that maximum value is 1. But remember, we're starting now at pi over 4, not starting on the x-axis. Then that shape, looks like this. So again, make that look like a cosine curve, not like a V. And so this would be an example where we use a C value for shifting to the left or right. Questions? All right, let's put a couple of those together then. How about y equals, let's just do a B and a C value. About sine of 1/2 times x plus pi over 2. Right, so we can see first, if you think about changing the period, it's going to be 2 pi over b, which is 1/2. So 2 pi divided by 1/2 would be 4 pi. And I can see that I'm shifting the graph by pi over 2. Okay, so if we're thinking about my period, normally I would be going from 0 to 4 pi. But I'm taking that and I'm shifting it to the, in this case, left, pi over 2. So instead of going 0 to 4 pi, I'm subtracting pi over 2 from each of those values. So I'm really going to be going from negative pi over 2 to 7 pi over 2. 4 pi minus pi over 2 less would be 7 pi over 2. Alright, so we want to think, I'll use the b value to get the new period, and then shift it however we need to shift it. Right. So, I can put down my negative pi over 2, and let's see. And 7 pi over 2. So to get the points in between, again, a foolproof way is to find the average. So negative pi over 2 plus 7 pi over 2 would be 6 pi over 2. Or that would be 3 pi, and then we would need to divide that by 2, right? Take the average. So halfway in between would be 3 pi over 2. Halfway in between 3 pi over 2 and 7 pi over 2 would be 5 pi over 2. Halfway in between negative pi over 2 and 3 pi over 2 would be positive pi over 2. So we don't have any other shifts. There's no a value, no d value. So I know that sine starts midline, goes up to the maximum, down to the midline, goes to the minimum, and back up to the midline. So here's what this sine curve would look like. So b value changes the period. Take 2 pi over b. C value then shifts that left to right. Questions? All right, let's do one where we've got all 4 values. Two cosine of 1/4 times x minus pi minus 1. So in this example, we've got an a, b, c, and a d value. The b and c values are probably where we want to start to figure out the key x values. So first, the period is going to be 2 pi divided by 1/4. So in this case, that period will be 8 pi. So normally, that would go from 0 to 8 pi, right? But we're shifting to the right pi. So if I'm shifting to the right pi, that means I'm going to add pi to both my starting and my ending values. So I'm really going to be going from pi to 9 pi. Right? So I can go ahead and put those x values on here. So pi and then 9 pi. So to get our key points then, we want to find the points in between like this. Okay, we're essentially cutting that into quarters. So halfway between pi and 9 pi would be 5 pi. And halfway between pi and 5 pi is 3 pi. Halfway between 5 pi and 9 pi would be 7 pi. So now we have to contend with our A and D values. First, the D value shifts the entire graph down 1. So we want to think about the midline. Okay, that shifts the midline to -1. Then the amplitude tells me I'm going to be going up to and down to from that midline. This is the cosine curve. So I'm going to be starting at the maximum value. My starting point is pi. If I'm going up 2 from -1, yeah, y value of +1. That's where my first point will be. My next key value is 3 pi. I know the cosine curve crosses the midline at the next key value. Then at 5 pi, the next key value is going to be the minimum. So I'm going down 2 from the minimum. So at 5 pi, my y value would be -3. My next key value comes back up to cross the midline. And then my final key value for the cosine curve is the maximum. So this is what this curve look like. One period of this curve. And I guess the important thing to remember is this continues on like this forever in both directions. Right? We're just focusing on graphing one period. Right? What questions do we have? Feel like we can do that on our own?